Fine. So one thing I forgot to mention before is that tutorials and labs start in week 1. So this week you will have a tutorial and lab. Your timetable might say that they start in week 2. Does it say that they start in week 2? Yeah, but they definitely start in week 1. The way things work in this course and in some other computing courses is that instead of lectures from week 1 to 12 and shoots from week 2 to 13, we have lectures and shoots from week 1 to 13, and then a week in the middle off to make up for it. So around the time when, you've got a lot of assignments and stuff to work on, we give you a nice break from having to turn up and listen to me talk, and you get that week to work on things yourself. Cool, I think that was everything. So shoots and stuff in week 1, and yep. Cool, so another question some people asked was, how do you get set up at home? What do you need to have on your home computer? All that sort of thing. So one thing we'll do in the tutorials and labs this week is we'll be looking into how to get your personal computer set up, whether that's a Windows computer, a Mac computer, or a Linux computer. If you're interested in trying out Linux, before I even get to that, so Linux is an operating system. Have any of you used or heard of Linux before? Okay, about half of you. So it's like how Windows is an operating system. This, lecture computer is running Windows, and we've got Macs as well, which are a different operating system. Linux is a different one again, or Unix. Linux is a type of Unix, so the words are sort of interchangeable for now. But it's a different operating system, so it works a little bit differently, but it's fairly straightforward to pick up. It's still got, the concept of like folders and files and programs, and it's the same as those like that. If you're interested in running it yourself, you could install Linux on your own computer. I think there's people who knows they're in InstallFest semester 2, semester 1 as well, maybe. So one thing we do have in the first semester is that the Computer Science Society run a thing called an InstallFest, where they'll help you install Linux on your laptops. That may or may not run this semester as well, but either way, it's something your tutor can help give you advice for. We also have instructions that you can follow for how to get set up on your home computer, so those will be on the course website. They've got, step-by-step things, install this program, like screenshots of showing you what to do. So we will definitely tell you how to do it. Like, don't stress just at this very moment if you don't know how to do that, because over the course of the week, we'll help you get set up. There's also a thing called VLab, which I'll show you in a second, which is like a virtual lab environment, but on your computer. So it's the Linux lab environment that they have, but you can run it from your own computer without needing to go to an actual lab. And it's graphical, and it looks exactly the same, and it's really, really cool. So, thinking of actually writing code. So I'm sure all of you have used things like Microsoft Word or Google Docs or Pages on a Mac to write documents and to write programs, right? So you can type things in there, and you can do things like make them bold and change the text color and all that sort of thing. And then if you tried to compile that into a program, the computer would go, "What are you talking about? This makes no sense to me." Computers need you to talk, like we said before, simply and specifically. And that means we write our programs in a thing that we call a text editor, which just does words, doesn't have formatting or colors or bold or anything like that. There are several different text editors you can use. The one we'll be using in the lecture and then in the labs is called gedit, but there are many, many other text editors, and we can post resources on the class website if you're interested in other ones. The programming language you'll be learning is called C, and the programming language in general it's sort of like a set of rules for how the language works. So if you think about English, I'm talking to you in English right now. English has rules, what are some rules of English? Like you have nouns, which are names of things, and then adjectives describe those. So instead of just saying, I've got hair, which is a thing, and it's rainbow, so rainbow hair. And just like any other language, programming languages have rules as well. Thankfully, they're a lot simpler than English. Anyone who's tried to learn English, it's a very, very confusing language, so you've done a very good job if you've learned English. Those of you who learned it at birth, you're very lucky because it's very confusing. So C's rules are much, much simpler. But programming in the C language or in any language means we can use the rules for how the language works that tell us how to describe a program, and we can use that to tell the computer, this is the program I want you to run, and then we can turn that into an actual program that the computer can run. So we can write our code and then turn that into like an exe file on Windows or equivalent that the computer can run. So let's jump straight into a demo. I'm going to show you how to log into the systems and how to write a very first, very basic program. You don't have to take notes or anything because the slides after this will have notes, but just watch and try not to get too confused. And if you're getting confused, wave your hand at me, ask questions, yell out, that kind of thing. So here is the wonderful thing called VLab. Let me do full screen. Yeah. Doesn't that thing go away? There we go. So I've gone just into a web browser, like just into Firefox or Google Chrome, and I can get into this. You can also install a program on your computer called a VNC viewer, and there's a zillion different types of those, and there'll be instructions for that as well. But if you're somewhere like a uni lectern computer where you can't install programs, you can log in through the web browser. And so this is what a lab machine will look like. If you go and sit down in front of the lab, you'll see it's got the uni logo, it's got School of Engineering and Computer Science, other way around. And then you log in. So your login will be your ZID, but my login is also my name. And then if you can type your password, you can. Cool, so you'll see this when you log in. It's a criminal offense to obtain data without permission and to damage, delete, alter, or insert data without permission, and it's like 10 years imprisonment in jail, so the laws for doing bad things on computers are very strict. But you can access your own account, and that won't be breaking any rules, and then it'll be fine. You can ignore this as just saying you can use this much memory and this much CPU, but that's irrelevant to us. And then you won't have this thing pop up because I haven't worked out how to get rid of that yet. So ignore that pop up. So you'll come into this thing and it'll look like this. You've got your desktop background, you've got this bar up the top where you can get an applications menu, and then some shortcuts down here for getting into various things as well. So the first thing I'm going to open is called a terminal. I'll make the text bigger. That's not the button to make the text bigger. Huge. People up the back, is that a good size to see, or is that too small? Too small? Okay, turn the lights down a bit. That's a thing I can try. That's apparently 50% lights. I guess the first half of the lights turned off. People in the front, is that too dark? No? Okay. I want that one to be off. Is that going to turn all of the lights off? As you can see, as a computer science lecturer, I am completely good at using all sorts of computers. I'll just keep pushing buttons. Okay. So people up the back, that was too small, you said, or is it okay now that it's... Does anyone think it's too small? You're pointing at the ceiling. What are you trying to tell me? Make it bigger? Okay. I don't actually know if I can. Yeah, that's what I'm thinking. So this is a terminal you'll see when you open yours, but I'm going to open a different one because I can make the font bigger in that. So you don't have to worry about knowing what I'm doing just at the moment. I just have to worry about knowing what I'm doing. So again, if you don't know what I'm doing, it's completely fine. You can use the one with text that's too small. Okay, people up the back, is this a good size? Bigger still? No? Cool. Okay, so you'll log into the lab computer, into VLab. You get this you know, the background type thing, you click on this terminal button here, and then this thing pops up, and it's got this thing, ZID at VX1, colon, a whole bunch of random words. Oh, that one's my name. So how many of you have seen a terminal or a command line or something like that before? Okay, more than I thought, maybe like a quarter of you. So if you haven't seen this before, I'm assuming you've used Windows or Mac or Linux or some sort of computer before. If you haven't used a computer before, this might be a little bit hard, but bear with me, it'll be great. So in something like, you know, a graphical interface, we can open folders and we can kind of click on things and we can go, oh, okay, here's my thing and I've got other files in here and I can click on things and that sort of thing. We can do the exact same thing in a terminal, and we can do pretty much anything we can do using a graphical interface and clicking buttons in a terminal. But terminals are a lot easier, not a lot easier at first, but once you know what you're doing and once you know how to use them, they're very, very fast and very powerful. So I'm going to just type the word clear to clear away that stuff I spammed. So you'll find you open your terminal, this thing pops up, you've got some stuff here and then this little blinking bit here, and this is where you type a command. So let's start with some basic stuff. So when you open the graphical editor, you can see the files that are in there. In a terminal, we can type ls, which stands for, I don't know what it actually stands for, I think it stands for list stuff. List something. It's probably actually got a real name that's better than that, but list the stuff in your folder. And so you'll see these words have popped up. I've got a thing called bin, a thing called download, a thing called gedit, a thing called misc, a thing called public HTML. And these are various folders or files that I have in the folder that I'm currently in. The one that I'm currently in is called my home directory. On Windows, you'd call it my documents. On Mac, I don't know if you also call it a home directory there. I'm not very good at using Macs. So we can list the files with ls. We can make a new folder or make a new directory with the command mkdir. So a directory is basically a folder. They're the same sort of concept. It's a thing that can hold files. So we have mk for make, dir for directory, which is like a folder. And then we've got to say what we want it to be called. So I'm going to call it COMP1511. So now if I list the files again, a thing's appeared called COMP1511. So now we want to open this folder, like move into this directory. And we can do that with cd, change directory. And then we can type the name of it, COMP1511. And then if I list the files in here, there's nothing in here because I've only just made it. So I mentioned before, you've got your home directory. It's sort of like your My Documents. You can refer to it with the squiggle. I believe its official name is the tilde. I call it a squiggle. So that's the one that's on like the top left-hand corner of your keyboard above tab. So instead of changing directory to like COMP1511, I can change directory to squiggle. And now it says I'm in the tilde directory, the squiggle directory. If I type ls, I'm back where I was before with all of my personal files. I'm not sure why it shows you this whole long version of it when you log in, but if that's really annoying, you can just type cd squiggle, and then you'll be in the same place, but it'll be less long and annoying. Cool. So let's do what we did before. Let's go into the COMP1511 folder. List the files in here, we'll see that it's blank. So we want to make a new code file. Like I said before, we need to use some sort of text editor to do that. We'll use the one called gedit. So just type gedit. So now I'm in a text editor, and I can type some stuff. This is not a very good C program, because it's not a C program at all. I can save it, so I'll do save as. It's going to tell me where to put it, so I'll go into my home folder, 1511. I'll call it something. Terrible name. And so now if I go back to my terminal and I try and type commands, it's not working. So Does anyone know what's going on? Because before I could type commands in the terminal, but now I can't. Say that again? I haven't closed the gedit. Yes, very true. So when I typed ls before, I was running a command basically, which is telling the computer, please do this thing. And listing the files is really quick. It just goes, okay, here's your files, I'm done. When I ran the command gedit, I said open this editor, but because the editor's still running, the program hasn't finished yet, so I can't go back to using the terminal. So I can close this manually with that little X button, and then all of the stuff that I tried doing before seems to have run. Oh, help. Help did something. Gave me some help, that's nice. One thing you'll find when you're using Linux, especially at first, but also for the rest of forever, is they have documentation, instructions on how to do things, and they're really confusing. Like looking at this, what do these do? How do I use these? I don't know. I know some of them because I've seen them before, but if you're looking at this and going, I don't know what's going on, that's totally fine. Over the course, we'll do a lot of looking into not just writing programs and understanding them, but sort of the technical processes of how these things work and how to navigate the confusing output you get, understanding error messages, being able to read the documentation and get the important stuff out. So it's a skill that you'll learn. So like I said before, I can type clear and everything will go away, nice and clean. So if I list the files again, my file called something is there. But let's write a C program. So I'm going to run gedit again, but I can do the sneaky thing where I put an ampersand in, or like an and symbol, Shift 7. And what this does, it'll open gedit just like before, but I can also still use my terminal, so I can still run commands. And what this does is this says, please run gedit, but run it in the background and let me keep using the terminal. So you'll find when you run gedit, if you have the ampersand there, you'll be able to use the terminal still. Cool, so let's write hello world program. So you'll find with programming, with many things really at first, it doesn't really make sense at first. You've just got to do these things and you don't know why you're doing those things. And then after a little while, you sort of start to understand why you're doing those things. So when we're writing a program, we sort of have the scaffolding that all programs will have, kind of the base structure. And if you haven't programmed before, this is going to be really confusing. So for the moment, just bear with me. You sort of just memorize how this works. And then as you go on and learn more programming, you'll be, I understand that now. So I'm going to make the font a bit bigger. Is that a good font size, people at the back? Too big, too small? If it's too small, wave your hand. Okay, no waves. I'm good. So, all right, writing a very first C program. So when you're starting out by writing a program, you want to keep a note of what you're doing. There's a thing we can put in programs called comments, and those are just a comment to ourselves, to the human reading it, rather than actually talking to the computer. So we start out with a thing called a header comment, which is describing what the program is and then saying who I am and the date. And we put that in all of our programs to start with. It's useful to have your name on your programs because then you know the years when you wrote them and you know when you wrote them. It's also helpful if you leave a flash drive somewhere and someone plugs in your flash drive and they go, oh, they did COMP1511, and they've got a source code file and it's got their name in it. So it's useful. So I'm going to do everybody's first program, a hello world program. This is a program that will just print out to the screen, hello world. So it'll display the words, hello world. So it's going to print out a friendly message. So I'll give it my name, and I'll give it my uni email address. So for you guys, that might be like ZID at UNSW. For me, it's going to be my actual one. You might find you have a name at student address, or you might have everybody has a ZID at UNSW address. You can also set up one with a name through the IDM somehow. Cool, and then today's date. So this is the way that I write dates. It's like official international standard on how you should write dates. The year, followed by the month, followed by the day. And that avoids the American versus not American, do we have the date or the month at the end. Cool. So The next thing on the list of things we just kind of memorize for now as part of our program, we have these things called hash includes. Oh no, I have to plug it on. Hang on. Ignore what I'm doing for a second. I just need to disable this thing. Okay, I was experimenting last semester with something that'll be confusing and break things. Cool, so I've written these lines hash include stdio.h, hash include stdlib.h. That's telling the computer also include other people's code that does this stuff. So again, for the moment, this is just a thing you'll memorize, and then soon it will be good. So every C program starts with an int main function, and that's the main function of the program. That's the thing that when your program runs, this will run. That's the main thing in your program. Functions are a thing that we'll get into soon, and what int means we'll get into soon. But for the moment, it's just another thing you've got to believe me works. I really hate it when teachers are just like, just believe me, this works, we'll tell you next year, and it's just like, ah. So I'm very sorry. Okay, so I typed these mysterious things. In programming, we have sort of blocks of code, and we have them inside these squiggle brackets. I think they're called curly braces or something. Again, squiggle brackets. And those are the ones kind of above the enter key on the left. Now that we're inside our squiggle brackets, we indent across that the code has some structure. So I'm going to, first of all, write a comment to say what I'm doing. Print out the famous, whoops, hello world message. Okay. As you can see, when you're typing in front of an audience, it's really hard to not make typos. So by printout, we don't mean like with a printer. And this took me so long to understand. I was like, why are we printing things? Like, where are the printers? What's going on? We mean print to the screen or display in the terminal. So I'm going to write this thing, printf hello world. So that's saying, print out these words, hello world. Followed by this thing \n, which means put a new line at the end. So rather than just staying on one line, when that's finished, move to the next line so that the computer can continue from the next line. Again, we'll get into this more soon. And then finally, return exit success. This is just telling the computer, hey, my program worked. So that the computer, when it's running your program, knows, okay, your program worked, cool. If there'd been some sort of error in your program, you could have a different thing like exit failure or something. But again, for now, one of those things we just do. So I'm going to save this. I type Control-S, you can hit the save button. I'm going to call this hello.c. And you'll notice that suddenly everything's gotten colors. When you're writing a C program, it knows that it's a C program, and so it highlights things to show you what's going on. So comments are a different color to code, so it's easier to read. It didn't know it was a C program until I saved it as hello.c. So if you want to have this nice highlighting while you're writing your lab code, make the file, save it, and then write the code, and it'll have the nice colors from the start. So I've got my program. I've got my terminal. If I list my files again, ls, you can see hello.c has appeared. So the next thing we need to do is to turn our source code into an actual computer program. I guess, pretend I didn't say that. I said nothing. How do I run this file? Just type it out and press enter? Like that? Cool. Hello.c command not found. Computer doesn't know what hello.c means. I'm sorry, you were close. But if I say like run hello.c, computer doesn't know how to run things. And computers actually can't understand source code. Like C code is written so that humans can read it and understand it, and computers can't read C code until we kind of transform it into a computer version. So we do that with a thing called a compiler. Again, I'll go into more detail on this in a minute, but we have a compiler called DCC, and we're saying, please compile a file, call the actual program afterwards hello. So like on Windows, that'd be hello.exe, for example. And the source code to compile is called hello.c. And hopefully that'll just work. Cool. If I'd had a mistake in my program, it would have spat out all of these errors and it'd be like, what's going on? But it's worked, so we've just got this. So now if we list our files again, we'll see we have one called hello. You'll see that it's green. On my terminal, it shows executable programs in a different color to things like source code. Now, to run this, you'd think I could just type hello, but again, the computer doesn't know what hello means. What I have to tell it is run hello that's in this folder that we're in right now. So I do that by saying /, in the folder that we're in right now, run the thing called hello. It's printed out hello world. Cool, and there is your very first C program, for those of you who've never written C code before. This is sort of the typical first program that people will write in any language. And you can go online and see like hello worlds and all these different programming languages, including really crazy ones like there's a programming language that's graphical pictures, and the way your picture is constructed depends on what your program does, and very crazy things. We're not going to learn that in this course. It's too confusing. But yes, there's our hello world. Cool. So now let's go to the slides, and I'll explain everything I just did. So people up the back, is that big enough to read? Yes, thank you. No complaints. So, like I said before, we've got this sort of scaffolding of our program, the basic thing. So we always start with a header message. We say, there's a simple line saying what the program's doing. We say who wrote it. So in the case of the questions that you do in pairs in the labs, you'll put both of your names there, and then the date. We've got these two hash includes, which I said before, and tell the program to use other people's code as well to do things like I/O input and output. And then we have this thing that I called the main function. So we have int main, int argc, char argv, bracket, bracket, then our open curly brace, then a closed curly brace down the bottom, and then at the end, return exit success. So all of your programs to start out with are going to look like this. You're going to have this sort of base structure, and then in the middle, you'll add specific to what your program is doing. And conveniently on the next slide, I've done just that. So here's what I had before, the comment saying to printing out the hello world message, and then printing out hello world. And again, if I didn't say this before, these slides will all be online. You'll be able to read through this, so you can read through all these notes, you can see everything that's done. And there'll be lecture videos as well, so if you want to watch the demonstration we've done, you can watch that again too. I didn't show this one. So there's a command we can do called pwd, which stands for print working directory, I believe, which tells you where you currently are. Like we saw before, there's ls. You can list the files in the directory. This is what they could have been. Those were not the exact ones that I had. Make dir to make a new directory. I didn't call it that either. I'm lying. I'm not doing what my slides say. Right, we can change directory. We can then print the directory again, and it'll show we're now in the new directory. The thing I didn't show, cd space ... means change to the previous directory. So I was in, Andrew B COMP1511, then I want to go back to just Andrew B. Writing a program, we have use our text editor like gedit. There are many other ones. You can use whichever one you want to use in the labs, but if you've never used one before, start with gedit because it's simple, easy to use. So then gedit hello.c, and then the ampersand, because that means it'll open in the background. And then to compile it, we use the thing called DCC. So DCC, compile my code, -o hello, call my program hello, and then hello.c, which is the source file. Cool. So when we're writing code, when we're programming, it's more than just kind of sit there, write the code, okay, you're done. To start out with, you want to think about the problem. Think about what you're actually trying to do. Write down proposed solutions. I'm sorry. Typos everywhere. So think about, what am I trying to do? What am I trying to solve? The Hello World program is quite simple because you just want to print out Hello World. But if you've got more complexity, like if you're trying to, what's a good example of something you can do? If you're trying to do anything at all that's more complex than print out Hello World, you want to think about, how are you trying to solve this? Then you want to think about your possible solutions. So rather than just right away going and coding, it's good to sort of think about, what am I trying to do? How am I going to do it? So you work out work out how you think you're going to do it, then break the steps into smaller steps. Trying to think of a good example. Maybe if you want to write a program that'll print out somebody's name and how old they are. So the problem is I want to have something that'll print out someone's name and say how old they are. I need to break that into smaller steps, so I'd have to break it into, print out their name. So I'd need to find out their name first. And print out how old they are, I'd have to find out how old they are. I convert those basic steps into instructions in the programming language. So in terms of printing out their name, I'd be using printf, like from before. In terms of working out their name and their age, that'd be something we'll look into later. Then we use an editor, like gedit, to create a file that contains the program, so like we had hello.c. We use a thing called a compiler, like DCC, to check the syntax of the program. And the syntax is sort of like the rules of the programming language, or the instructions in the code, so the actual C code of the program. Then when we've got our compiled program, to make sure that it works, we test it on a range of data. So for example, if I had a program that would print out someone's name and age, what are the possible inputs I could give it for name and age? Any examples? Anyone? Person in the front row with red hair, who I know. What's your name? What's your age? Okay. So I could give the input for name as Curtis and the age as 21. But what about if I gave it the name as like randomly bashing keys, or like the name as the number 50, or the age as, in words rather than numbers, like, TEN for 10, or the age as -1. Can you be -1 years old? Not really. So it's important when we're writing our programs to not just assume that they're going to work, and not just assume that people are going to use them how we think they'll use them, but to test that they don't break if they do crazy things. Again, this is something we'll get into a lot during the course. And then compiling our programs. Our C program has to be translated into machine code to be run. So like I said before, we write our code in C, which is a language that humans can understand. And then the compiler will turn that into a thing called machine code, assembly language, which computers can understand. I might show you after this what that looks like, and then you can see why it's good that we don't write that by hand. So this is called compilation. It's performed by a compiler. The compiler we'll use in this course is called DCC, which is actually a kind of custom wrapper around a compiler that's called Clang. Another one that's often used is called GCC. So you might see in like online tutorials or anything, or lecture slides from years and years ago, using GCC. And pretty much anything that works with DCC works with GCC and vice versa. So there's a compile line of like, have GCC, blah, 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 blah. You can just change the G to a D and run it in DCC. Okay, so that's it for right now. Let's go back in here. So I forgot to show you the pwd command before. So print working directory, show me where I am. So it shows I'm in this thing import/ravel/2/andrewb/comp1511. And what that means is that there's a folder kind of at the very top somewhere, or the very start, called import. Inside that there's a folder called ravel. Inside that there's a folder called 2. Inside that there's a folder called andrewb, and inside that there's a folder called comp1511. So it's like in in Windows, how you have like your My Computer is sort of the start of everything, and inside My Computer you've got like C drive and D drive, and inside C drive you've got like Windows folder and programs and stuff like that. In Linux we just start at the /. So we can move up a directory with cd space ... It's important that you have the cd, the space, and the ... If we just have cd dot, we're going to end up in the same place as we are at the moment. Nothing's going to change. And if we don't have the space, it'll say, I don't know what's going on. So we can go up even further. We can go into this one, import ravel2, and that contains a whole bunch of people's folders. So mine was in here somewhere, maybe, Andrew B. But these are a whole bunch of other people at CSE and their home directories. I very much hope that I can't go into their home directories and see their stuff. This won't work, right? Okay, so I can go into their folder, but then I can't actually view their files, which is really good because otherwise I could, like, I don't know, steal their assignment code or wreak havoc in their thing. So technically I am in the folder of this person, cmil254, who is sitting here and did say it was okay, but I can't actually see any of their files. We'll get to that in a minute, maybe next week. We can technically possibly view some files, but that's slightly more complicated. Cool, and so we can keep going up to higher directories. Now we're in Ravel, which has folders called 1, 2, and 3. I'm guessing they're like separate things that hold people. Yep, that's got a whole bunch more users. We can go up even further. They're in the folder called import, which has atoms, cage, glass, Kamin, Ravel. And these are all CSE servers that hold people's files. If I go up even more, I'm now in this thing called slash. And this looks pretty similar on all Linux computers. You've got folders. Okay, no you don't. You've got folders called things like bin, boot, etc, and so on. It's fine if this is confusing, you don't need to know this stuff. But I can sort of keep going cd ... until I hit the top. And if I try doing that again now, I can't go anywhere else because I'm already at the start. So if I go back to my home directory, I can see these files I've got here. What else do I have in here? So, two useful tricks. I've been typing these things out by hand, right, COMP1511, but you can do something called tab complete, where you start typing it and then you hit the tab key, which is the one above caps lock, and it'll complete it for you, which is really nice. So like CD and then hit tab and it completes it for me. This is really good because it means you can't make typos. So if I were trying to CD to COMP1511 but actually type COMP1611, it'll go no such file or directory. But if I tab complete, it'll only let me go to the one that exists. Oops. And if you have caps lock on, things in capital letters won't work. Clearly an intentional example. So tab complete is one cool thing. And another thing, you can print out what's in a file and show it in the terminal without having to open gedit. So with a command called cat, which is nothing at all related to the animal, I can type cat and then the name of the thing I want to look at. So with cat hello.c, it'll show me the source code for my file. But if I type cat hello and I open the compiled program, what's going to happen? Any thoughts? Any ideas? Anyone? It won't work? Nothing will happen? Yeah? It'll give me hello world? It'll be a mess? Let's run it. I hit enter. I'm waiting. There we go. I would have thought it'd move and scroll through, but maybe I just... Ah, I see. The internet's apparently too slow for it to scroll. Well, it seems to have frozen. It doesn't normally break everything. I guess it's a very large file. So this stuff you can see here is the computer machine code